Hi everyone. Today we are going to talk about 8.5 exponential function continuously compounded. So last time we learned the exponential function interest compounded many different ways of compounding, right? But today we are going to find the amount of balance of savings account or population changes when the rate is compounded continuously. Okay, so let's review for a second for compounded interest. So we talked about semi-annually, quarterly, or monthly, and if it is needed, daily also. So this is the formula. Amount A is equal to what? P, principal, times 1 plus interest rate, that's a decimal, divided by N. N is N in the power N times T. So N is the number of times that the interest is compounded, and the T is the how many years, number of years. Then semi-annually case, if interest was compounded twice a year, that we call semi-annually or biannually, right? Bi means two. So in this case, your formula will be A equal to P times P principal times 1 plus I divided by 2. So compounded twice. And then in the exponent, 2 times the number of years, T. Quarterly, instead of 2, you put the 4, right? Quarterly means compounded 4 times a year. And monthly, interest compounded 12 times a year. So instead of 2 or 4, you put the 12 year divided by 12, and then multiply 12 to the time. And if it is daily, what do you do? N will be 365, right? So when the interest compounded daily, it will be 365. All right, but today's work is continuously compounded, which means so we learned that the more you compound, the more amount. So think about it. If you compound continuously, like infinitely many times, then we can assume that this will be give us the biggest amount of the balance, right? So, but the formula is completely different. So you should remember A equal to what? Amount is equal to principal P times E. E is is an irrational number like pi, but the value is 2.718281. Keep going like this. So E to the R times T. R is the interest rate. Okay, so to make it easier to remember, I say this PERT. So P-E-R-T, but R times T is in the power. But here, we should be careful. One thing to be careful is sometimes the interest doesn't decrease, right? But if you have like a population can increase, but sometimes also can decrease. So what happens if the rate is decreasing or decay case? In that case, the formula will be same PERT, but in the power, you should have a negative here. That makes difference. So if you have a negative in the power here, same PERT, same formula, but negative in the exponent, right? Then that will make it decrease. All right. So let's see with the example. So interest was compounded continuously. Annual rate is 8%. And opening account with a $6,400. After 6 years, how much money will be? So which compounding gives you the most? So let's do it yearly, monthly, and continuously. So yearly, once a year, but monthly, 12 times a year, continuously, infinitely many times compounding, right? We know the answer. Which one is the most? Number 3, continuously. But how much? Let's figure out. So A is, so if it is a continuous compounding per principal time amount is 6,400, E, you can find E in the calculator, and in the power, 8% is R rate is 0.08. Now how many years? 6 years, end of the 6 years. So 6 years later, you multiply 6. Then you get the $10,000, 342.88 cents. So how about monthly? If you put the function like the 6,400, 1.08 to the 6th power, right? Which is $10,156. How about monthly? Formula, sorry about this. This is a denominator 12. So 1 plus, you should be careful. Don't add the 1 and the 0.08 first and divide. That's the common error, right? You should divide the 0.08 by 12 and then add to 1. And 12 times 6 in the power, you will get 10,326.41. So yearly, 10,156. Monthly, $10,326.41. If you get daily, you divide by 365 here, multiply here 365, right? It'll be a little more than this, but it'll be smaller than continuously compounding. So continuous compounding, we already got it, 10,342.88 cents, right? So which one is the most? Yes, continuously compounding case the most. So now this case is a decreasing case, right? Decreasing. So the population was decreasing at a rate of 3.9% per year. So think about it, population, if there's nothing saying about the compounding, we need to use a common sense. Population, people that deliver the babies, or some people die, not under certain time, right? It is happening randomly, continuously. So we usually use continuously compounding, all right? So if the population in 2010 was approximately 790,000, then what is the predicted population for 2015, which is how many years later? 5 years later, but decreasing case. So we use per, but decreasing, we put the negative in the power, right? So let's use this. It's actually error analysis. So if you see that, if you see quickly here, so with per, this person, what was the error? This person used the formula per properly, yes or no? No, you're supposed to put the negative here. That was an error, right? So that's why it increased. It's supposed to decreasing though. 3.9% with a 3.9% rate, the population was supposed to decrease, but it increased. Why? There was no negative. So what should you do? You put the negative in the exponent here, then you will get 675,891.76. You can round it from later. So it decreased, right? So you're good. So we'll stop here.